Welcome to Semiconductor News Decoded. I'm Ty, with 31 years inside the semiconductor industry, bringing you the real view from the factory floor. Today's topic: Huawei's announcement of a new technology called the Tau scaling law, designed to work around EUV restrictions, and their claim that it could achieve performance equivalent to 1.4 nanometer class chips by 2031. As always, I'll explain everything in the most simplified way possible. Even a middle schooler should be able to follow along. If you're a specialist watching, some parts may feel oversimplified, but I'd like to prioritize giving everyone the big picture first. Think of today's story as a chef who can't use the latest kitchen tools, but finds a completely new way to keep up. So sit back and enjoy. Here's the one-line version of today's news. A chef who can't access the latest kitchen equipment announced they can match the speed of the finest restaurants just by rethinking the entire layout of their kitchen from scratch. This chef can't get the same tools as their top-tier rivals, but rather than giving up, they made a bold declaration. Instead of better equipment, I'll redesign the kitchen itself. Until now, the standard approach for chefs was the finer you can slice your ingredients, the faster your cooking becomes. Sharper knives, smaller cutting boards, always pushing toward greater precision. But this chef found themselves in a difficult position. Those state-of-the-art knives were monopolized by their rivals, and there was simply no way to get them. So what did this chef come up with? The idea of folding the kitchen workflow itself. They realized the real bottleneck wasn't the knife work. It was the time it took to pass ingredients from station to station. By redesigning the kitchen layout in 3 dimensions, they could dramatically cut that travel time. This is the core idea behind Tau scaling, reducing the time it takes for things to reach the next step in the process. The goal on the table: match the speed of the finest restaurants by 2031. This isn't a triumphant victory cry. It's more of a survival strategy. I've found a viable path with the kitchen I already have. And to be fair, this chef has already developed 381 original recipes in-house, so the depth of preparation behind this announcement is very real. Let me map this analogy onto the real world. The chef who can't access the latest equipment is Huawei. The rival restaurant monopolizing the best equipment is TSMC, the world's top semiconductor manufacturer, along with ASML, which supplies those machines. Folding the kitchen workflow maps to Tau scaling law and logic folding. Matching the finest restaurant speed is the 1.4 nanometer class performance target, and 381 original recipes represents 381 chip designs. Rather than lamenting what tools they can't access, Huawei is designing its own path forward. From here, I'll explain how this plays out in the actual industry. Let me summarize the kitchen analogy stance. Now, let's get into the real details. The star of this announcement is HiSilicon, Huawei's in-house chip design division. HiSilicon's head, He Tingbo, officially unveiled a new performance framework called the Tau scaling law. The backdrop is straightforward. U.S. export restrictions have cut Huawei off from EUV lithography machines. And honestly, my read on this story maps almost perfectly onto that kitchen analogy. Let me first explain what Tau in Tau scaling law actually means. Traditionally, semiconductor performance has been driven by Moore's law, the idea that shrinking transistors makes chips faster. Tau, on the other hand, refers to signal propagation delay, the time it takes for a signal to travel inside the chip. So Tau scaling law is about improving performance not by shrinking transistors, but by reducing how long signals take to arrive. Why did Huawei take this approach? The direct reason is clear. EUV lithography machines are specialized exposure tools that use extremely short wavelengths of light. They're essential for manufacturing at the 3 nanometer, 2 nanometer, and 1.4 nanometer nodes. These machines are almost exclusively supplied by ASML, a Dutch company, and US regulations now ban their export to Chinese companies, including Huawei. Without the latest equipment, competing through miniaturization simply isn't an option. This is where HiSilicon's proposed logic folding architecture comes in. Rather than laying out circuit components flat on a chip, The idea is to stack and fold them in 3 dimensions, physically shortening the distance signals have to travel. Instead of making transistors smaller, the entire approach is to rethink how they're arranged and connected. This is a path toward performance improvement that doesn't depend on EUV equipment. The announcement suggested that 1.4 nanometer class performance could be achievable by 2031. But here's an important distinction. 1.4 nanometer class performance and manufactured on a 1.4 nanometer process node are 2 completely different things. When TSMC or Samsung talk about 1.4 nanometer, they mean physically shrinking transistor sizes, a manufacturing technology. What HiSilicon means by 1.4 nanometer class is achieving equivalent operating speeds through a different architecture, which does not directly correspond to a manufacturing node number. One of the most striking figures in He Tingbo's announcement was 381 chip designs. This is the number of distinct chips that HiSilicon has designed in-house over the years, clear evidence that Huawei has been steadily building its own semiconductor design capabilities for a long time. Beyond the Kirin series for smartphones, they've accumulated designs spanning telecom equipment, AI, automotive, and IoT. That number tells a real story. That said, I want to be direct about something. The number of designs and the capability for mass production are 2 very different things. Being able to design 381 chips is not the same as being able to mass produce them at cutting-edge yields. Currently, Huawei's chips are manufactured by SMIC, a domestic Chinese foundry, which only has access to DUV, an older generation exposure technology. When it comes to high-volume manufacturing at the leading edge, a significant gap still remains. For AI applications, though, the picture shifts somewhat. In AI inference, running a trained model in production, you don't necessarily need the most cutting-edge miniaturization. A brute force approach, connecting large numbers of chips in parallel, can be quite effective. Huawei has already released its Ascend series of AI accelerators. With NVIDIA products blocked from China by US sanctions, Ascend has become a go-to alternative domestically, and demand is strong. In the AI space, I believe there's real potential for competing through volume. Military and national security applications are another matter entirely. Military chips prioritize reliability, environmental durability, and supply stability, but there are certain contexts where cutting-edge performance matters too. From my perspective, as someone who's worked in the industry, the performance gap between what TSMC and Intel can manufacture at the leading edge and what Huawei can currently achieve remains substantial. The advantage of leading-edge processes in military applications is still very significant. I've linked a related note article in the description today. Please check it out. The title is, "Isn't being forced to think only short-term a sign of distress?" The Tau scaling law announcement is technically fascinating, but when you look at the context that made it necessary, it's fundamentally a detour around a blocked road, the EUV and advanced miniaturization path that was the original destination. The 2031 target date may also reflect the reality that looking much further ahead is simply too difficult right now. This is what it looks like when drawing a 10-year technology roadmap has become nearly impossible. To put it plainly, this announcement should be read as Huawei's survival strategy, not a declaration that TSMC has become irrelevant. It's a declaration that says, given that we can't use TSMC, we're redesigning the battlefield on our own terms, and it's a near-term target at that. The architectural insight behind logic folding is genuinely worth recognizing, but whether it actually reaches 1.4 nanometer class performance needs to be validated through real products and actual mass production. Right now, this is still at the stage of plans and concepts. Let me pull today's content together. The Tau scaling law, announced by HiSilicon's He Tingbo, is a new approach to achieving performance improvements without EUV equipment. Rather than shrinking transistors, it focuses on shortening signal propagation delay, called Tau, inside the chip, and introduces an architecture called logic folding for 3-dimensional circuit placement. The target is 1.4 nanometer class performance by 2031. The track record of 381 chip designs is real, but design capability and cutting-edge mass production capability are separate things, and the gap with TSMC and Samsung at the production level still exists. In AI, volume-based approaches have potential. In military applications, the advantage of leading-edge processes remains intact. My conclusion? This is a genuine survival strategy forged under pressure, not a victory declaration. Tau scaling law is a technically interesting idea, and the depth of design capability is undeniable. But from a realistic standpoint of how to survive the next 10 years, this is clearly an alternative born out of necessity, because EUV wasn't available. What strikes me is that being able to build the cutting edge and having a different path to compete with the cutting edge are fundamentally different kinds of strength. Whether Huawei can deliver on either will be validated through actual products as 2031 approaches. This is one to keep watching. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.